Let's solve a problem about dividing money between two people. We need to divide 60 rupees between A and B, where B gets 12 rupees more than A. Let's visualize this with a diagram. Here's our total amount of 60 rupees. We need to divide it into two parts, A's share and B's share. And remember, B's share needs to be 12 rupees more than A's share. Let's solve this step by step. First, let's say A's share is X rupees. Then B's share must be X plus 12 rupees. Since the total amount is 60 rupees, we can write the equation X plus 12 equals 60. This simplifies to 2X plus 12 equals 60. Now, let's solve for X. First, subtract 12 from both sides. This gives us 2X equals 48. Then, divide both sides by 2, and we get X equals 24. Therefore, A's share is 24 rupees and B's share is 36 rupees. Let's verify. 24 plus 36 equals 60, and 36 is 12 more than 24. Perfect. And that's how we solve problems involving dividing money with a given difference between shares. Remember to 1. Let the smaller share be X. 2. Express the larger share in terms of X. 3. Set up an equation based on the total. And finally, solve for X. Let's solve the equation negative 12y equals 108. To solve this equation, we need to isolate y. Remember, the goal when solving equations is to get the variable by itself on one side of the equals sign. To solve for y, we need to divide both sides by negative 12. This is because multiplying or dividing both sides of an equation by the same non-zero number maintains the equality. On the left side, negative 12 divided by negative 12 equals positive 1, leaving us with just y. On the right side, we need to perform the division of 108 by negative 12. When dividing by a negative number, the result will have the opposite sign of the number being divided. 108 divided by 12 is 9. And since we're dividing by negative 12, our final answer is negative 9. Let's verify our answer by plugging negative 9 back into the original equation. Negative 12 times negative 9 equals positive 108, confirming our solution is correct. Therefore, y equals negative 9 is our solution. Remember, when dividing by a negative number, the sign of the result will be opposite to the sign of the number being. Let's solve this equation step by step. We start with 18 plus m equals 8. To solve for m, we need to isolate it on one side of the equation. Let's visualize this on a number line. We start at 18, add some unknown value m, and end up at 8. To find m, we need to find out how far we need to move from 18 to get to 8. In other words, we need to subtract 18 from both sides of the equation to isolate m. Now, let's simplify. 8 minus 18 equals negative 10. Therefore, m equals negative 10. Let's verify our answer. If we plug negative 10 back into our original equation, 18 plus negative 10 equals 8, which confirms our solution is correct. To summarize what we did, we started with 18 plus m equals 8, subtracted 18 from both sides to isolate m, and found that m equals negative 10. We can think of this as finding how far we need to move from 18 to get to. Let's solve this linear equation step by step. We start with 3x minus 4 equals 5. To solve this equation, we need to isolate x on one side. Let's visualize this as a balanced scale, where both sides must remain equal. Our first step is to get rid of the negative 4 on the left side. To do this, we add 4 to both sides to keep the equation balanced. When we add 4 to the left side, it cancels out with a negative 4. Now we have 3x equals 9. To isolate x, we need to divide both sides by 3. Remember, whatever we do to one side, we must do to the other side to keep the equation balanced. Let's verify our solution by plugging x equals 3 back into the original equation. 3 times 3 minus 4 equals 5. 9 minus 4 equals 5. 5 equals 5. Therefore, x equals 3 is the correct solution. In summary, we solved this equation in 2 steps. First, we added 4 to both sides to get rid of the subtraction. Then we divided both sides by 3 to isolate x. Our solution is, let's solve a simple age calculation problem. Radhika is currently 5 years old, and we want to find out how old she will be in 5 years. Let's visualize this with a timeline. Here's a timeline showing Radhika's age as time passes. Right now, she's 5 years old, and we want to know her age after 5 more years pass. Let's solve this step by step. We start with Radhika's current age, which is 5 years. Then we add 5 years to get her future age. Therefore, in 5 years, Radhika will be 10 years old. This makes sense because each year that passes adds 1 year to her age. To summarize, starting from age 5, let's learn how to identify linear expressions. A linear expression has variables with a degree of 1, meaning the variables are only raised to the first power. Let's examine 4 different expressions and determine which one is linear. Here are our options. Option A, x squared plus 1, option B, y plus y squared, option C, 1 plus z, option D, just the number 4. Let's analyze each option. First, let's look at option A, x squared plus 1. This expression contains x squared, which means x has a degree of 2. Since linear expressions can only have variables with degree 1, this is not linear. Next, option B, y plus y squared. This expression has both y and y squared. Since it contains y squared, which has degree 2, this expression is not linear. Let's look at option C, 1 plus z. This expression only has z to the first power. There are no variables squared or multiplied together. This makes it a linear expression. Finally, option D, just 4. While this is technically a linear expression because it's a constant term, it's not the best example since it doesn't contain any variables. Therefore, the best example of a linear expression is option C, 1 plus z. It's the best choice because, first, it contains a variable, second, the variable is only raised to the first power, and third, there are no products of variables. Remember, when identifying linear expressions, look for variables that are only raised. Let's solve this linear equation step by step. Our starting equation is 5z plus 2 equals 6. To solve this equation, we need to isolate the variable z. Let's visualize this like a balance scale. Whatever we do to one side of the equation, we must do to the other side to keep it balanced. Our first step is to subtract 2 from both sides of the equation. This will isolate the term with our variable z. After subtracting 2, we get 5z equals 4. Now that we have 5z equals 4, we need to divide both sides by 5 to get z by itself. Remember, dividing both sides by the same number maintains the equality. Therefore, z equals 4/5. This is our solution. We can verify this is correct by plugging 4/5 back into our original equation. Let's check our work. 5 times 4/5 equals 4, plus 2 equals 6. Therefore, our solution z equals 4/5 is correct. In summary, we solved this equation by first subtracting 2 from both sides, then dividing both sides by 5, and finally, let's solve a word problem about Rajesh's age. The problem states that in 18 years, Rajesh's age will be 4 times his current age. Let's visualize this with a timeline. Here's our timeline showing Rajesh's age. Let's say his current age is x, and in 18 years, his age will be x plus 18. According to the problem, his age then will be 4 times his current age. Let's solve this equation step by step. First, let's subtract x from both sides of the equation. This gives us 18 equals 3x. Now, let's divide both sides by 3 to solve for x. This gives us x equals 6. So, Rajesh's current age is 6 years old. Let's verify our answer. If Rajesh is currently 6 years old, then in 18 years he will be 24 years old. And 24 is indeed 4 times his current age of 6, so our solution is correct. Let's summarize what we did. First, we represented Rajesh's current age as x, then we wrote an equation based on the problem statement. And finally, we solved the equation using algebra to find that Rajesh is 6 years old. Let's solve this problem step by step to determine if the statement is true. If x equals 4, then x plus 7 equals 4 plus 7. Let's start by writing out what we're given. We're given that x equals 4. And we need to check if this statement is true. X plus 7 equals 4 plus 7. To solve this, let's use substitution. Since we know x equals 4, we can substitute 4 wherever we see x in the equation. Now, let's simplify both sides of the equation. On the left side, for plus 7 equals 11. And on the right side, for plus 7 also equals 11. Since we got 11 equals 11, which is a true statement, we can conclude that the original statement is true. Let's review what we did. First, we substituted x equals 4 into the equation. Then, we simplified both sides of the equation. Finally, we found that both sides were equal, proving the statement true. This example demonstrates how. Let's learn about what makes an equation a linear equation in one variable. A linear equation is a special type of algebraic equation with specific characteristics. Let's look at some examples to understand what makes an equation linear. Here's our first example. 3x plus 5 is equal to 10. This is a linear equation because it has one variable, x, and x is only raised to the first power. Let's examine what makes an equation not linear. Here's our first counterexample. X superscript 2 plus 2 is equal to 8. This is not linear because the variable x is raised to a power greater than 1. Here's another non-example. 2x plus 3y equals 6. This isn't a linear equation in one variable because it contains two variables, x and y. So, what exactly makes an equation a linear equation in one variable? Let's break it down. First, it must have exactly one variable. Second, that variable must be raised only to the first power. Let's look at some more examples to reinforce our understanding. Here are some valid linear equations in one variable. 2x plus 3 is equal to 7-5x equals 10x/2 equals 4. The general form of a linear equation in one variable can be written as x plus b equals c, where a is the coefficient of x and is not 0, b is the constant term, and c is the value on the right side of the equation. In conclusion, a linear equation in one variable must have exactly one variable, and that variable must be raised only to the first power. This makes option D one variable. Let's solve this problem step by step. We need to find what number, when subtracted from 4/7, gives us -2/7. Let's visualize this on a number line. Here's our number line with some fractions marked. We start at 4/7 and we want to end up at -2/7. The distance between these points represents the value of x that we're looking for. To solve this algebraically, let's start with our equation. 4/7 minus x equals -2/7. To isolate x, we'll add x to both sides of the equation. The x's cancel out on the left side, leaving us with 4/7 equals -2/7 plus x. Now, let's add 2/7 to both sides to isolate x. On the left side, we can combine 4/7 and 2/7 to get 6/7. On the right side, -2/7 plus 2/7 equals 0, leaving us with just x. Let's verify our answer by plugging it back into the original equation. 4/7 minus 6/7 equals -2/7. Therefore, 6/7 is the correct answer. Looking back at our number line, we can see that 6/7 represents the distance we needed to subtract from 4/7 to reach -2/7. This matches our algebraic solution perfectly. In conclusion, we found that when 6/7 is subtracted from 4/7, we get -2/7, making 6/7 our answer. Let's understand what the right-hand side, or RHS, of an equation means. In any equation, the equal sign acts as a divider that splits the equation into two parts, the left-hand side, or LHS, and the right-hand side, or RHS. The right-hand side is everything that appears to the right of the equal sign. In this equation, the right-hand side is simply 18. When solving equations, we often need to perform operations on both sides to isolate the variable. The right-hand side helps us keep track of what we're doing to both sides of the equation. Since 18 is the only number to the right of the equal sign, the right-hand side is 18. Remember, identifying the to isolate x, we multiply both sides by 7. This simplifies to x equals -56. Let's verify. Plugging -56 into the original equation gives us -56 divided by 7 is equal to -8. Here's a number line visualization. Therefore, x equals -56. Let's understand why a linear equation is called a simple equation. A linear equation is considered simple because it only involves basic operations, multiplication and addition. Here's an example of a linear equation. Y equals mx plus b. Notice how x only appears to the first power, and we only use multiplication and addition. Let's visualize what makes this equation simple. When we graph a linear equation, we get a straight line. If we pick any point on this line and another point, the rate of change between these points remains constant. This consistent behavior is what makes linear equations simple to work with. In contrast, let's look at other types of equations that are not considered simple. A quadratic equation involves x squared, while a cubic equation involves x cubed. Their graphs are curves, not straight lines, and their rates of change are not constant. Let's summarize why linear equations are called simple equations. First, they only involve basic operations, multiplication and addition. Second, they produce straight lines when graphed. Third, they have a constant rate of change. And finally, they don't involve any powers higher than 1. Therefore, when we refer to a linear equation as a simple equation, we're acknowledging its straightforward nature and basic mathematical operations. This makes it the most fundamental type. Let's solve the equation 2x equals 18 step by step. Here's our starting equation. To solve for x, we need to isolate it on one side of the equation. Think of the equation like a balance scale. Whatever we do to one side, we must do to the other side to keep it balanced. Since x is being multiplied by 2, we need to divide both sides by 2 to isolate x. Remember, dividing by 2 is the same as multiplying by 1/2. Now, let's simplify 18 divided by 2. We can think of this as splitting 18 into 2 equal groups. 18 divided by 2 equals 9. Therefore, x equals 9. Let's verify our answer by plugging 9 back into the original equation. 2 times 9 equals 18. The equation balances, so our solution is correct. In summary, we solved the equation by first identifying that we needed to divide both sides by 2, then performing the division to get x equals 9. And finally, let's understand what we mean by the degree of a linear equation. The degree of an equation is the highest power of the variable in that equation. Let's look at some examples of linear equations. Here's a simple linear equation. Y equals 2x plus 3. Notice that x has a power of 1. Even though we don't write it explicitly, this is really 2x superscript 1 plus 3. Let's look at another example. Here's another linear equation. 3x minus 5 equals 10. Again, x has an implied power of 1. Let's visualize what makes an equation linear. When we graph a linear equation, it always forms a straight line. This is because the highest power of the variable is 1. To better understand why linear equations always have degree 1, let's compare them with other types of equations. Here's a quadratic equation which has degree 2, y equals x squared plus x plus 1. And here's a cubic equation which has degree 3, y equals x cubed minus 2x squared plus x. Let's summarize what we've learned about linear equations. 1. A linear equation always has variables raised to the first power only. 2. When graphed, a linear equation always forms a straight line. 3. Therefore, the degree of a linear equation is always 1. Therefore, for question 14, which asks about the degree of a linear equation, the correct answer is B. Let's understand why a linear equation typically has exactly one solution. A linear equation is an equation of the form x plus b equals y, where a and b are constants and is not equal to 0. Let's look at an example. 2x plus 3 equals y. When we graph this equation, it forms a straight line on the coordinate plane. This is why it's called a linear equation. Now, let's understand why this line represents all solutions. For any x value we choose, there will be exactly one corresponding y value that satisfies the equation. For example, if x equals 1, then y must equal 5, giving us the point 1, 5. This is true for any x value we choose. Each x value corresponds to exactly one y value, creating exactly one solution point on the line. There are 3 important cases to understand about linear equations. First, a normal linear equation like we just saw has exactly one solution. Second, if we have something like 0x equals 0, we get infinitely many solutions. This is called a dependent equation. And third, if we have something like 0x equals 5, we get no solutions. This is called an inconsistent equation. However, in standard form, where is not equal to 0, a linear equation will have exactly one solution. Therefore, the correct answer to our question is D, 1. Remember, this is because each x value in a linear equation. Let's solve this equation step by step. Our goal is to isolate y on one side of the equation. Here's our initial equation. Y minus 3 equals 10. To solve for y, we need to get rid of the minus 3 term on the left side. Remember, when solving equations, whatever we do to one side, we must do to the other side to keep the equation balanced. To isolate y, we need to add 3 to both sides of the equation. Adding 3 to both sides will cancel out the minus 3 on the left side. On the left side, negative 3 plus 3 equals 0, leaving us with just y. On the right side, 10 plus 3 equals 13. Let's verify our answer by plugging 13 back into the original equation. If we substitute y equals 13 into y minus 3 equals 10, we get 13 minus 3 equals 10, which simplifies to 10 equals 10. Since this is true, we know our solution y equals 13 is correct. Therefore, the solution to the equation y minus 3 equals 10 is y equals. Let's learn about the left-hand side, or LHS, of an equation. Consider the linear equation 2x equals 3. The equal sign acts as a divider in any equation, splitting it into two parts. The left-hand side, which is everything to the left of the equal sign, and the right-hand side, which is everything to the right of the equal sign. In this equation, the left-hand side is 2x. By definition, the LHS is everything that appears to the left of the equal sign in an equation. Let's look at a few more examples to better understand this concept. In the equation x plus 2 equals 5, the LHS is x plus 2. In 3y minus 1 equals 0, the LHS is 3y minus 1. And in z squared equals 9, the LHS is z squared. So, returning to our original question, in the linear equation 2x equals 3, what is the left-hand side? The LHS is 2x, as it's the part of the equation that appears to the left of the equal sign. Remember, identifying the left-hand side of an equation is as simple as looking at what appears before the equal sign. This is an important concept in algebra that helps. Let's solve a problem involving two numbers that add up to 120. We'll use algebra to find these numbers. Let's start by representing our two numbers algebraically. Let's call the first number 5x and the second number 7x. We know that these two numbers add up to 120. This gives us our equation. 5x plus 7x equals 120. On the left side, we can combine like terms. 5x plus 7x equals 12x. Now we can solve for x. To isolate x, we divide both sides by 12. This gives us x equals 10. Now that we know x equals 10, let's find our two numbers. For the first number, we multiply 5 times 10, which gives us 50. For the second number, we multiply 7 times 10, which gives us 70. Let's verify our answer. 50 plus 70 equals 120, which matches our original requirement. Therefore, the two numbers are 50 and 70. Let's summarize our solution process. This problem demonstrates how we can use algebra to find two numbers. Let's understand how many solutions a linear equation can have. The question asks us, the number of solutions to a linear equation is underscore, 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 underscore. Let's understand this through some examples. A linear equation can be graphed as a straight line on a coordinate plane. Let's take a simple example: x plus y equals 4. When we graph this, we get a straight line. Any point on this line is a solution to the equation. For example, if x is 0, y would be 4. If x is 2, y would be 2. And so on. In fact, there are infinitely many points on this line, which means there are infinitely many solutions. However, this is not what the question is asking. The question is about a single linear equation in one variable. For a linear equation in one variable, like 2x plus 3 is equal to 11, we can solve it by subtracting 3 from both sides to get 2x equals 8, then dividing both sides by 2 to get x equals 4. This gives us exactly one solution. This is true for any linear equation in one variable. The key point is that a linear equation in one variable will always have exactly one solution, unless it's a contradiction or an identity. Therefore, looking at our options, a 2b, 3c